So here we are, Chapter 2, College Algebra 2.1a, and that's why we've got a green color instead of a black background as we're in another chapter. So it's just kind of a reminder that we've changed. And we're going to skip the first few pages. It's talking about linear equations, and linear equations, as you know, are equations that when you graph them, you get a straight line, and some basic algebra stuff. I'm not even sure why they go over this in a college level course, but we're going to start in example 3, which is basically going to linear models, which means basically story problems. So anyway, example 3. So Americans spend about $511 billion dining out. They spent that much in 2006. This was a 5.1% increase over the amount spent in 2005. How much was spent in 2005? All right, so what we're going to do here is familiarize ourselves. Bottom of page 178 gives us some steps to problem solving. So we're trying to familiarize ourselves, trying to figure out what they're giving us and what they're asking for. That's one of the biggest problems with story problems, is not knowing what kind of an answer they're looking for. So we're looking at how much money was spent in 2005 given the bit of information that they gave you in the story problem. And another option they give you is to make a drawing, if that helps, make a list, do all kinds of different things in order to familiarize yourself better with the problem. The second step is to translate, and third is carry out, 4 is check, and 5 is state. So really 4 and 5 are not really part of completing the problem. It's just making sure you got things right. All right, so let's familiarize ourselves with it. All right, so $511 billion was spent dining in 2005. I don't know why they're doing the estimate thing, but anyway, in 2006, I mean. Okay, this was a 5.1% increase over the amount spent in 2005. All right, what are we going to do with those those figures there? 511 billion and a 5.1% increase. All right, so my familiarization is going to be different than what theirs is. My familiarization says that $511 billion, let's just use 511, we'll stick the billion on it later. $511 was spent in 2006. This was a 5.1% increase over the amount we spent in 2005. So we're increasing what we spent in 2005, and when we increase it, we get 511 billion. Okay, so we know that when we took the amount we spent, this is 2006. When we took the amount we spent in 2005, because we don't know that, that's what we're looking for, and we increased it by 5.1% plus 5.1%, we get 511. Okay, so how does that look? We have the amount we spent in 2005. We increased it. Increased what? We increased the amount we spent by 5.1%. So 5.1% of 5.1% of the amount we spent equals 511. All right, let's look and see what we've got. The amount we spent in 2005, we increased the amount we spent by 5.1%, and you find that increase by 5.1% times whatever we spent in 2005. So here's the increase, here's the amount we spent. So the increase plus the amount we spent gives me my amount in 2006. All right, so let's change. Always have to change your decimal or your percent to a decimal if you're going to do any math with it. We're going to add this to 1, and we get 1.051x equals 511. Divide by 1.051, that goes away. We get a number similar to or close to $486 billion. Okay, and that's the answer that we get for that. Now again, I did it kind of the same as the book, but I just kind of did my ordering a little bit different. But it's that whole translating thing. It's trying to get an idea of what you're looking for and how you're going to get to where you need to go based on what we're looking for. All right, let's look at example 4. Okay, so we have dogs and cat owners. So together, a dog owner plus a cat owner spends an average of $376 a year on expenses on vet bills. Okay? Well, we're not working with two variables here. Okay, so we're going to stick with one variable. So let's see if we can figure out how to do that. A dog owner spends $150 more than a cat owner. So let's say a cat owner is a C for cat. A dog owner spends $150 more than the cat. Okay, so I just changed my variable to C's, comparing it to the cat. We don't know anything about cats, but we do know that the dog's owners spend $150 more than on a cat because dogs are worth more than cats. Dogs have a purpose for living, cats do not. So of course you're going to spend more on a dog. Okay, so cats, see, we know the least amount because they're worthless, and we know the most about the dogs because they have some value. Now I'm just joking around about the worthless and the value. Well, not really, but anyway, that has nothing to do with the math problem. So what we have now is we've got two variables. We've got the amount we spend on a cat and the amount we spend on a dog. So instead of the D, I'm putting a C plus 150 equals 376. Okay? So that's not too bad. So if I want to find out how much we spend on cats, I would go to C plus 150 equals 376, subtract the 150, and I get 150, 67, 170, or 226, I'm sorry, I don't know what I'm thinking here. 226, C then equals 113. So if we spend $113 on a cat, then in order to get our $376 we spend on animals, we know that we're going to have to spend on our dog $263. So 263 plus 113 gives us our $376 annually. All right, let's jump over to example 5. And before we get on to example 5, let's look at the motion formula. Distance equals rate or speed times time. Okay, that can also be written as rate equals distance over time, or time equals distance over rate. It's just a manipulation of this initial one here into different formulas depending on what you're looking for. One of the things that you have to remember when you're dealing with these problems, sometimes they will give you more information than you need. And sometimes the numbers in there you may never even use. But that's down the road a little bit. But they do give you a bunch of random stuff that you really don't care about. Like America West Airlines fleet includes Boeing 737s and de Havilland Dash 8 200s. And I mean, we don't care about all that stuff. What we care about is what they're looking for. All right, so we've got two different airplanes, 737 and a Dash 8. The 737 goes 500 mile an hour. The Dash 8 goes 302. Okay, that we need to know that. A Dash 8 takes off and travels at its cruising speed. An hour later, a 737 takes off and follows the same route, traveling at its cruising speed. How long will it take the 737 to overtake the Dash 8? All right, so what I like to do for this one and what they did with theirs is have ourselves a handy-dandy little drawing. Takes us our mind off the misery of doing this kind of problem. So it's cruising along here. Boy, that's a really straight line, isn't it? And it's going 500 miles per hour. Okay, so we've got the dash 8. That's a pretty straight line too. And it's going 302 miles per hour. We don't know the time, but we do know that the dash 8 left at a certain time, let's call it t, and the 737 left at a certain time. We can't call them both t though because the dash 8 left an hour earlier. So it's been in the air an hour longer when the 737 takes off. Okay, so the 737 will be in the air an hour less than the dash 8 because it left an hour later. So if if the dash 8 started at 8 and this one started at 9, then this one is going to be in the air an hour longer than the time on the 737. So this is t plus 1. Okay, we could have made this t and made this t minus 1 because it's in the air an hour less than this one, but I'd rather do the plus. And we're looking for how long will it take. So we're looking for time, but we've also got this distance. They're both going to go the same distance, right? Because we're interested in when this plane will catch up to this one. And this plane and this plane will have gone the same distance, obviously, when they catch up. So our d's are the same. So our d, distance of the 737, is equal to the distance of the dash 8. Okay, well, if that's the case, and we know that d equals rt, then we can say that the rt of this plane equals the rt of this plane, right? All right, so let's make a table here. Just maybe tables make it easier for you. And so we have distance. The distances are the same, right? Because we're just interested in when they catch up. When they catch up, then we're done. Our rate, our speed. What is the rate? 737 is 500. Rate of the dash 8 is 302. And then our time. Our time of the 737, our time of the dash 8. Okay, so sometimes that table makes it easier. All right, so again, I said that the distances are the same. So what is the RT of the 737? 500T. What is the RT of the dash 8? 302 times T plus 1. Okay, we're going to say that they're equal to each other because this is distance and this is distance. RT is the same as distance, and the distances are the same, so our RTs are the same. And then you just do the math to figure out what T is. But this is the general formula. Once you get that formula, you should be able to do fine and figure it out from there because you'll find the time. And the time is going to be a little more than an hour and a half. All right. I am going to stop here and we'll start with the next video and go into interest.